Hello guys. So today we are here to solve this problem. This problem is called all paths from source to target. And in this problem, we are going to find all the paths from node labeled 0 to the last node of that graph. So this is a directed acyclic graph. This is a directed acyclic graph, and we are going to find all possible paths from node 0 to node n-1, which is the last node, and return them in on any order. So see here, we are going to create this solution vector. Okay. And each component can either be added to that list or it may not be added to that list. Okay. So having done that, what we can do that we'll go ahead, we'll go ahead and we will go ahead and create the solution of this problem. So how are we going to do this? First of all, let's see what we are being asked here. We are asked to take this path 0 to 1 and 1 to 3, 0 to 1 and 1 to 3, and put it in a list, and then 0 to 2 and 2 to 3. So put it in, this is the second path. Put both of them in the list. Okay. So now to do that, what we are going to do, we are going to do list of integer. Okay, this is the result, and then we are going to pass it. Done. And then list of integer path is equal to new array list. Okay, and we are going to solve this problem by using backtracking technique. As I said, that we are going to create a solution vector here, and any problem wherever you have to create solution vector where you can either pick one solution or leave that out. So here, if any path is going to the destination, then you are going to pick that path. Otherwise, you are leaving that. Okay, so at leaf nodes you are going to make the decision whether this path is successfully reaching to the destination or not. If it is not, then you are leaving it out. Okay, if the source is not destination is equal to destination, if the node under consideration is not equal to destination, then we are not taking it up. Okay, so let's name this our method as backtracking. And in this backtracking method, we are going to pass this graph and the starting node, which is 0, and the ending node, which could be graph -1, the last node, and then the path, because we are going to build the path component by component. And once the path is successfully reaching this destination, then we are adding it to the result. And at the end, we are returning what? We are returning the result. See here, we are not taking this result, we are not taking this result as part of our uh, taking this result as part of our saving this result. We are not returning anything from the backtracking method. Why? Because result is being passed as a argument, and that argument, so that argument, uh, it's an object reference. Result is an object of list of integer type. So it's a reference type, and the reference type are stored on the heap. And when you pass this reference, then the other function also is pointing to that same heap object. So whatever changes you are doing in this backtracking method, those changes are reflecting in the this all path source target, this previous method also. So this is the reason why we are not passing it, or we are returning it back from the backtracking method. um, okay, and then we need to pass this list of integer path. Okay, sorry, excuse me. And then we need to pass this list of integer result. Path dot add. We are going to add the start. Okay. And if start is equal to destination, correct? Yes. If it is equal to destination, then we are going to result dot add new array list of path. Why we are doing this new array list of path? Because because we are creating a new snapshot of this path object, and we are saving this snapshot or clone of this path object into the result list of lists, because subsequently we may change this path. We may need to remove the things from this path object. Okay, because we'll be traversing back from the leaf to the root, and in that process we'll be removing the nodes. Okay, now having said that, now what to do here? Okay, so we can write it like this also. Else, for I is equal to 0, I less than. Okay, and then afterwards we can directly recursively call this graph, and then start, and then destination, and then path, and then result. Okay, and but once we are coming back from that backtracking method, then we have to remove the last entered path. And I think we are done. We don't need to do anything else. See how easy this solution has been. Let me just run it. What's the problem here? I is equal to 0, I less than graph of. For and I is equal to 0, I less than graph of. Oh, correct. We need not do backtracking with the start. We need to do backtracking with the start का ith location से. Okay, now we are good to go. Perfect. And this is beating all the other solutions. So see how easy it is to come out of that Stack Overflow error just by planning, putting the right thing over there. We are able to do it. Thank you. Thank you. If you have any other doubt, if you are facing some other problem, let me know. I'll help you out. Okay. Thank you.